Kia ora. This atomic electrons configuration simulation is very useful to help you link not only the energy levels and the orbitals to the periodic table, but it also helps you with the electron configuration, and you'll learn about the noble gas notation later on in this lesson. So if you have a look, we call this first two groups here the S block, and helium actually should also fit in here just for this, because notice if I click on hydrogen, it has an atomic number of 1, so it has 1 electron and it goes into the lowest energy. If I click on helium, then that is filled. If I click on lithium, its valence electron is in the S, so is beryllium, so is sodium. The last set of electrons are always in the S block, and we can go down like this. Notice that the last electrons are always in the S block, so these first two are the S block. This over here, this block in the middle, is called the D block. So if I say, for instance, click on titanium, notice that the last electrons are in the D block. So if I click on any of these in the D block, although we have electrons elsewhere, the ones where they are last, the highest area is always in the D block. If I click in this area, all of them apart from helium, it's what we call the P block. So if I click from aluminium, there is 1 electron in the 3B P, then silicon, 2 electrons in the 3P, phosphorus, 3 electrons in the 3P, as you can also see over here, sulfur, chlorine, and argon. And now we get back to the S block over here. So use the periodic table to help you work out the electron configuration, because you'll notice it's 1s, 1s1, 1s2. 2s1, the second row, so it's 2s. The last valence electron is in the 2s, and it's in the first column, so it's 2s1. Second row, second column, 2s2. If I go over here, we're now in the P block. So it's in the second row and third column, so we're P1, P2, P3, P4, P5, P6. Now, if we go down here, we are in the third row. So it is now in the third energy level. So it's 3s1. Notice we've got this abbreviation of neon for that, Ne. So it's got exactly the same electron configuration up to neon plus this extra electron. So magnesium, a third row, so it's in the third energy level, second group, or group 2, so it's 3s2. Aluminium, we're now in the P block, so we know that the last electron always has to be P, so it's P1, P2, P3, P4, P5, and it's always 3P5 because it's in the third row. We get to argon. If I go to calcium, so you can see that calcium, argon is the noble gas just before it, okay? So it has the same electron configuration as argon plus these extra ones. So it's in the fourth row, so we have got 4s, 1, because I've only got 1 electron being in the group 1. Group 2 has got 2 electrons, so it's 4s2. Now it gets the tricky bit, because what we have here now is the 3D1. So this transition metal block has actually sort of like dropped an energy level. So although this is in the fourth row, it's actually still the third energy level. So you can see it over here. It's actually higher in energy than the 4s, even though it is closer to the nucleus. And if you click through here, you'll notice that there's an anomaly. So S2 suddenly becomes S1. Find out later in the lesson. We get to manganese and we can click through and it will all be in the D block. Notice again an anomaly. And then we get to zinc. And then we've now got the D block filled, and now we get on to the P block. And we're in the fourth row, so it now will be 4P. And you can see how this gets filled up here, all singly, and then they start pairing up. Just like if you were on a bus and you were filling up the bus, the ones closest to the bus driver gets filled up first, one at a time. So if I go there, and then another one perhaps doesn't want to walk that far, but then otherwise people start sitting singly. So the more you have to move out, the more energy it takes. So you're less likely to go further on, but you don't want to sit very much with somebody else, some stranger. So you like to sit singly. So when we're in this area, you can see they're all single, and then they only when you have to make an extra effort of going further that you may start pairing up. So it's an approximate analogy, because sometimes you can have the whole bus just having single people sitting on the seats. So explore the simulation, look at how the atomic number adds up. All these small superscript numbers adds up to the atomic number, so you can use that as a check to see if you've made any errors. See how you fill them up, which gets filled before which other orbitals. Have fun. Goodbye.